welcome to the video on IOLink solutions. My name is Anju. I am an application engineer at Analog Devices. In this video, I am going to introduce some of the IOLink reference designs from Analog Devices. IOLink is a point-to-point communication between master and device. The master can have multiple ports, but device will have only one port. Master can also power the connected device or sensor over cable. The L+ line provides power supply from master to slave, and L- is the ground line connection. Communication is performed at 24 voltage level and it must be within 20 meters with unshielded cables using standard connectors. For this demo, I have with me MAXREFDES145, an 8-channel IOLink master reference design. This design consists of USB connector for PC interface and FTDI for USB to SPI conversion. It has two digital isolators for the SPI interface, a microcontroller, and four MAX14819 dual channel IOLink master transceivers. It allows for simultaneous testing of 8 different sensors or actuators. It has a 24 volt power connector for power supply. For the slave devices, I have with me MAXREFDES171. This is an IOLink distance sensor. This design is based on MAX22513 IOLink device transceiver. It also has MAX32660 ultra low power 16-bit microcontroller and a VL53L1 distance sensor. This IOLink sensor can measure a distance up to 4 meters. Another slave device is MAXREFDES278. An IOLink 8-channel solenoid actuator based on MAX22514 IOLink transceiver. It has a low power microcontroller for interfacing MAX22514 to MAX22200. MAX22200 is an octal integrated serial controlled solenoid driver. This reference design can be powered either through the IOLink master or from external power source. To make sure no current flows back to the IOLink master, this design uses MAX17608 current limiter. To start with, download the IOLink control tool software. TE Concept IOLink control tool is available for download from the MAXREFDES145 product page. Make sure you download the latest version of the software. This software does have IODD file import capability. In next step, let us make the hardware connections. Connect the distance sensor MAXREFDES171 to channel 1 and solenoid actuator MAXREFDES278 to channel 2. Plug in USB to the PC for interface and connect the reference design to 24 volt power adapter. Once these connections are done, let's move to GUI. In the FTDI USB SPI interface area of the GUI, click refresh button. The GUI automatically finds the IOLink master. Then click connect button. Here you can see 8 different port options are available. Since MAXREFDES171 is connected to channel 1, we will use port 1 tab. Then click select the device button. Load the IODD file for MAXREFDES171. IODD file can be downloaded from the reference design product page and import. The GUI also allows to automatically download the IODD file from IODD Finder in the Select Device menu. After installing the IODD file, press on Power On and then for IOLink connection, press on IOLink button. Once we press Power On, we can see the red LED on MAXREFDES145 channel 1. This shows 24 volt is available for sensor. The green valid printed near to PD input in GUI indicate the device is connected properly. Now we can see reading from the distance sensor in channel 1 under process data inputs. When I am going close to proximity sensor, correspondingly the values are varying. Let's start with MAXREFDES278. Follow the same procedure shown before to load the IODD file. Click Power On, then click IOLink to connect. For this demo, we are connecting a 24 volt DC solenoid to the actuator channel 2. You can read the default configuration settings in the parameter menu on the top. Click on Device Parameterization. Select the Channel 2 CFG tab since solenoid is connected to Channel 2. Click on Read Selected on the top menu. You will get all the parameters listed with their default values. If you want to make any configuration changes, double click on the parameter value, select the required settings from the drop down menu. Then click on Right Selected option on the top. MAXREFDES145 has two modes to enable driver channel, SPI and trigger mode. The default settings are for SPI mode as shown in the configuration tab. If you want to change it to trigger mode, select Trig option in the Trigger Select tab. Then change the Trig A under Process Data Output to True. We will use the default SPI mode for now. Then to enable the actuator channel, you have to set the half bridge on off byte under Process Data Output tab. To drive channel 2, set it to 2. When the channel is enabled, we can see solenoid is energized and plunger is pulled in. For more information, visit our website. That's it for this video. Thank you for your time.